one of the best ways to do rotation is about the origin. Now you're going to learn in higher level math how to do it with about different ones, but the origin, remember, is just the point 0, 0 on a graph, and so it makes it actually a lot easier if we keep it that way. And so we're actually going to memorize two ways of rotations, and you can actually do them together, and you can actually get larger rotations, or you can do multiple ones of these. But I'm going to go 90 degrees, so we're going to be going this direction about our rotation. So we're going to go from P to P prime. We're going like this. Notice if I rotate 90 degrees, what happens? My mapping, which is, this is huge, you know this, goes x, y, maps onto a negative y, x. So they flip and the y negates. So that's when you're rotating 90 degrees. Now what if I do it 180 degrees? Well, the mapping, the arrow notation for this, which is huge when you're working with it, you are going to go xy goes to negative x, negative y, and this is really how it happens. And let me explain a little bit here. If you don't want to write this down, that's okay, but this is huge, you know this. Notice, could I draw two right triangles right here? Right? The distance from here to here, by the way, it's supposed to be the x-axis, is x, but to go 180 degrees, that's a negative x going this direction. Notice I go up y, but I end up going down y to get there. So your rotation is going to take you a whole 180 degrees as you end up negating your x and y. And it's all because of right triangles and stuff when you're doing that. But again, notice I rotated counterclockwise. Notice counterclockwise rotation. Alright, so let's do this real quickly with this one. Again, here's going to be the directions. I don't know if I say this well on your homework or not. I don't have that right in front of me. But always show your arrow notation, because sometimes I'm going to ask you to do that instead of graphing it, which makes it a lot easier. So here's the first one, is I want to rotate triangle JKL by 180 degrees about the origin. So I'm going to go here 180 degrees. So my mapping, when I do this, is going to be xy going to a negative x, negative y mapping. So we're going to have our j, which is at 2, 2, k, which is at 4, negative 5, oops, makes that a parenthesis, l is at negative 1, 6, so j prime is at negative 2, k prime is going to be at negative 4, positive 5, L prime is at 1, negative 6. So let's go ahead and mark these. J's at 2, 2. K's at 4, negative 5. And L is over at negative 1, all the way at, well, excuse me, I was at, yeah, negative 1, 6. Make sure I was saying this right. So it's this long, narrow is my original. So we have here our points. Remember, the origin is just marked, so don't connect that. I was thinking in my brain to connect it earlier, so don't do that. So that's your original image. So I want to do my pre-image. So my pre-image, we're going to be at negative 2, 2. Right here, so there's J prime. We're going to be at a negative 4, 5. So we go negative 4, up 5. About right here. That's your K prime. Notice it gets flipped 100. I love this. You can literally see 180 degrees. 180 degrees to the origin. It works so cool. And then L prime is at 1, negative 6. So we're right here. So when I do this long, narrow triangle again, I should be using my note card to make these lines straight. I'm just being a rebellious math teacher today, knowing I can't draw straight lines. But you should see the rotation 180 degrees through. You can see the 180 degrees through. You can see the 180 degrees rotation through with this. So it's a pretty cool one. Let's do the same type of idea with a 90-degree angle. Now remember, when we're rotating at 90 degrees, I still want to use my arrow notation. So I know I've got my x, y, but my rotation ends up being a negative y, x. So I flip-flop and my y becomes negative. So notice I changed that to 90. So hopefully you guys have that on your paper here. So A is at 2, negative 1. A prime is going to be at 1, 2. B is at 4, 1. B prime can be at negative 1, 4. C, which is at 3, 3, is at C prime, which is at negative 3, 3. So let's go ahead and do this. I'm going to do my original one first because I love seeing the physical rotation on this. A is at 2, negative 1, so that's A. B is at 4, 1. And C is over at negative, oh, excuse me, C is at 3, 3. Boy, making sure I was going straight to the prime here. So that's my original diagram. And then A prime is going to be at 1, 2. B prime is at negative 1, 4. And C prime is going to be at negative 3, 3. If you look at this, look at the angle formed, right angle for B. A right angle being formed, C. A right angle being formed. You literally can see all the right angles that are there. So it's kind of cool. Now let's have fun and do one more example. It's kind of a fun Ferris wheel example of all things, but this is kind of a rate and time type problem as well. So we kind of want to think about this for a little bit. All right, so a Ferris wheel has a 100-foot radius and takes 60 seconds to make a complete rotation. A chair starts at 100, 0. After 5 seconds, what are the coordinates of its location to the nearest tenth? So how in the world are we going to be able to figure out this problem? So first of all, let's treat that the axis of the Ferris wheel is on the origin at 0, 0. So we're going to draw the x and y axis. X, y. So this is going to be our 0. The radius is at 100 feet, so it starts at 100, 0, right here. Okay, and then it rotates, so it's going to stay, the radius is going to end up staying here, okay, over at, for, was it about 5 seconds? So we know my radius still stayed at 100. How in the world am I going to find the coordinates of its location if I rotate it after 5 seconds? Well, we're going to use right triangles to help us figure this out. And we have to use also degrees with minutes and stuff. All right, how many seconds, my friends, are in a minute? Because notice it says 60 seconds to make a complete rotation. So 1 minute around. This would like be really fast, right? It'd be a blast. If 60 seconds, if I go 5 seconds of it, so we go 5 over 60. Don't you agree with me? That's really 1/12 of the ride all the way around, because the Ferris wheel goes all the way around. Well, if it's 1/12 of it, what is 1/12 of 360 degrees? So 1/12 of 360 degrees is going to be 30 degrees, which means I rotated 30 degrees. Oh, look, what type of triangle do we have? 30, 60, 90. So our short leg would be 50. Our long leg would be 50 root 3. So what is going to be my coordinates? Well, your coordinates are your x and y values for this. So that's 50 root 3, and this would be 50. So if I plug this into my calculator to the nearest tenth, I get 86.6, and then I get 50. And those would be in like feet. So that would be your new rotation. Kind of a fun thing to do.